So if you have only the rectangle, it can be the resistor, and if you draw an arrow through it, it is nothing but the variable resistor. So this component is nothing but the variable resistor. This is nothing but the variable resistor. Now, what is the use of this variable resistor? We had already seen in the potential divider or voltage divider that this is a variable resistance means what? We can change the value of the resistance, and if you change the value of the resistance, we can control the current flowing through the circuit. Okay, so we can say purpose is to control the current. Purpose is to control the current across the heater, because our component is over here is the heater, and we can control the current across the heater. We can also write down to control the potential difference or voltage across the heater. Anyway, you can write down to control the current across the heater, or you can also write down to limit the current across the heater. Okay, so now the part B of the question. The heater is designed to work from 3.6 volt supply, okay, and it has a power rating of 4.5 watt. So these ratings are very important. You can see 4.5 and 3.6, okay, at this voltage. By considering the current in the heater, try to calculate the resistance of the component X when there is a correct potential difference across the heater. So we want to find out what is the resistance. We need to find out what is the resistance of the resistance of the component X. This we need to find out. Okay, and the ratings of the heater are given, that is 4.5 watt and the 3.6 volt, that is the potential difference. So first of all, we need to find out the current flowing through the heater. That means the current flowing through this entire circuit. The current will be flowing is a constant. Suppose the current is starting from this positive terminal of the battery and it is moving towards the negative terminal of the battery. The current throughout the circuit will remain the same because it is a series circuit. Okay, if you switch this on. So first of all, we need to find out the current, and for that we will use directly the power rating formula. This formula we have seen several times, P is equal to VI, and we can use directly this formula to find out the current through the heater. There is no need to use any other formula. So I can write down over here P is nothing but equal to VI, okay, and that's why what should be the I should be equal to P divided by voltage, okay, P divided by voltage. So what should be the value of P, that is given 4.5 watt, divided by the voltage is also given. This is given in the rating only, that's why we are going to calculate the current 3.6. So if you calculate 4.5 divided by 3.6, you can get the value of about 1.25 ampere. You will get the value of 1.25 ampere. So this is the current flowing through the heater, and of course if this current is flowing through the heater, the same current must flow through this variable resistor, because this is a series circuit, so current across the entire circuit should remain the same. Okay. And what we need to find out, the resistance of component X. So in order to find out the resistance of component X, we should know what is the potential difference across this variable resistor and the current flowing through this variable resistor. So current, we found out the value using this the power rating values of the bulb, that is 1.25, and current flowing through the resistor is same. Now we need to estimate what is the potential difference across this variable resistor. We know that in the series circuit, what happens? Current remains the same, but the potential split. Okay, you have to remember this thing. In the series circuit, what happens? The current remains the same, but the potential difference split. And what happens to the parallel circuit? the potential difference remains the same, but the current split. This is a series circuit, so current remains the same, but the potential difference is split. And what is the potential difference across this power supply here? Across this heater, it was nothing but 3.6 volt. Okay, 3.6 volt. Okay, so if I assume this, the potential across this variable resistance is nothing but V. Okay, so this V plus 3.6 should be equal to 6. Okay, because the potential difference that is provided by the battery is 6 volt and that is split across all the components, and there are only two components, variable resistor and the heater, and it will split across this resistor and the heater value we already know 3.6. so what should be the value of the potential difference across the variable resistance? That should be equal to 6 minus 3.6, right? Because 3.6 plus V should be equal to 6. So the value of the potential difference across the heater, here I will calculate the potential difference across the heater. V should be equal to, across the heater, V should be equal to 6 minus 3.6 value. Okay, that is coming out to be 2.4 volt. Okay, so why it is 2.4 volt? Because this 3.6 plus V should be equal to 6. So what I needed is nothing but the current through the variable resistor and the potential difference across the variable resistance. Why do we need these two values? These two values we need to find out the resistance across the resistance of this variable resistor, and that we can find out by using simply the Ohm's law now. So Ohm's law is what? Nothing but V. Ohm's law is nothing but equal to V is equal to IR. Okay, so using this formula, what is R? R should be equal to V divided by R. If you rearrange this, I will go to the left hand side, it will go into the denominator. So R is equal to V divided by I. So what is the value of the potential difference we just found? That is 2.4. And what is the value of the current? That is 1.25. So if you calculate this value, that is nothing but 2.4 divided by 1.25, it is coming out to be 1.92 ohm. Okay, so this should be the value of the resistance across the resistance of the variable resistor. That should be the ohm. So I can write down this again over here. That is nothing but 1.92 ohm. So I hope you understood this numerical. I will explain again. See, we need to find out the resistance across the resistance of this variable resistor. So for that we need to find out the current flowing through this variable resistor and the voltage across this variable resistor. To find out the current, we use the power rating values of the heater, and we have used P equal to VI formula. From using this formula, we found 1.25 where the current flowing to the circuit. So same current should flow through this variable resistor because this is a series circuit, and in the series circuit the current remains the same, but the potential split, and that's why this 6 volt potential should split across this resistor and the heater. So 6 should be equal to V plus 3.6. That's why V should be equal to 6 minus 3.6. So V is equal to 3 minus 6.6, that is equal to 2.4. So that way we found the current through the variable resistor and the potential difference across the variable resistor. Why did we need it? Because we can use this Ohm's law to find out the resistance. So V is equal to I, so R is equal to V by I, and that's why it is 2.4 divided by 1.25. So our ohm of the variable resistor is coming out to be 1.92 ohm. Now the third C part of the problem. Sometime after the heater is switched on, the ammeter reading is seen to have decreased, and suggest why it is happening. So the current is continuously flowing through the circuit, and the ammeter is connected to find out the current. After some time, what happens? The temperature of the heater is increasing, and so what happens to the current rating? So what happens when the